Hello everyone, how are you? I hope you are fine. Let's solve another problem. This time we are going to solve problem number 29, divide two integers. So it's just dividing two integers. Divide the dividend by a divisor. It's of medium difficulty, but the catch here is we cannot use multiplication, we cannot use the division, and we cannot use the mod. So the question, okay, how we will be able to divide without using these methods? We can solve it. There's also another assumption, which is the numbers are 32-bit signed integers. So the range will be from minus 2 to power 31 to positive 2 to power 31 minus 1. Okay, so let me explain how division work. First, let's assume we want to divide 10 by 3. In other words, we can say how many 3's there are in 10. By the way, the answer it's required to be an integer number without any decimal point. So it will be round down. So 10 divided by 3, the answer will be 3 because there's 3 3's in 10 and what's left is 1. So in other words, what we can do, we can simply say, okay, let's take this number and subtract 3 from it. So 10 minus 3 is 7. So far, the result is 1 because we found 1 3 in 10. We check 7 with the 3. Is 7 bigger than 3 or not? So if 7 is bigger than 3, then that means 7 still have more 3's on it. So we say, okay, let's subtract 7 from 3. Here it's 4. And we increase the result by 1 because so far we found 2 3's in 10. And then 4 minus 3, the left is 1 and the result is a 3. So far the result is a 3 and what's left is 1. 1 is less than a 3, so we stop here and then we return the result is a 3. Very easy. And this is if both of number are positive, or if both of them are negative, we can remove the negative sign because the answer will be positive. But what if one of them is negative and the other is positive? What we will do, we will convert it into absolute value, both of them. Any of them, if negative, we will convert it to absolute value. And we store the sign in another variable. And we do the same operation, 7 by 3, the result will be 2. And later we will say because the sign was negative, so the result will be negative 2. We will multiply the result by the sign. So no, we cannot multiply. We put if condition because he says here we cannot multiply. So far it's easy, very clear. Let's try another example. 100 divided by 3. So if we always say 100 minus 3, the result is 1, then 97 minus 3, the result will be 2, and so on. You see the point. It will take long time. It's not very efficient way. So is there a better way? Yes. We can say 100, how many 3's in it? Or what if we shift the 3 to the left? We say it's 30. So 30, when we shift decimal to the left, is like we are multiplying by 10. I know there's no shift for decimal in Python, but this is the way I'm explaining things, and later we will solve it in binary. So 30 means 10 times 3. So okay, let's try with 30. It will be faster. We say 100 minus 30 is faster than 100 minus 3 minus another 3 and minus another 3. So here we say 100 minus 3, the left is 70 and the result is 10 because we shift 3 to the left, so it's 10 3's. And then 70 minus 30 is 40 and the result will become 20, another 10. And 40 minus 30 is 10 and the result will become 30. This is another 10. Now we cannot subtract 10 from 30 because 30 is bigger than 10. But still the divisor is 3 is less than 10, so we return back the 3 to the right side and say 10 minus 3 is 7, it will become 31, and then will become 32, and then become 33. And this is the result, 33. So we play with shifting and we solve it in 1, 2, 3, 4, 5, 6 iteration. While if we only subtract it from 3, it will take 33 times because the result is 33. So you find it's clear now shifting is better. Okay, but shifting in decimal does not exist. So how we can solve it in a good way? Let me bring the other slide here. We will do the subtraction. We will deal with the numbers using the binary form. So 10 is 1010 and 3 is 11. So okay, first I'm gonna shift 3 to the left, and in binary shifting number to the left it's like multiplying it by 2 because it's binary, it's of 2 possibility. So instead of dividing 10 by 3 or it's like 100, I will come to this example here. So we shift it to the left and we say 10 minus 6, the result is 4, and then 4 minus 3, the result is 1. From here we take 2 because 6 is 2 threes, and from here is 1 because it's 1 3, the result is a 3. Let me show a better example here. 100 divided by 3. This is, I'm shifting from right to left. It's not the best way. The best way is if we shift from left to right, because we will shift maximum 31 times. While shifting from right to left, it could take more than 31 times, and the condition, it will be more difficult. You can try it. So I will give you the direct solution. Of course, in the code I will use 31-bit, but to save space, I'm using how many? 1, 2, 3, 4, 5, 6-bit. But it's same idea. Instead of 6, we'll start from 31-bit, then we go to 30-bit, and then 29-bit, shifting like this. So what I'm gonna do, we have 100 divided by 3. In binary, this is the 100, and this is 3. Okay, I will shift 3 6 times to the left. Actually, I will start from the 6 times to the left. I will start, okay, and we say, is this number lower than this number? If yes, we can subtract. And if we subtract it at this point, actually this is 7 times. Sorry about that. 7 times. 1, 2, 3, 4, 5, 6, 8. Okay, 7 times, not 6. If we manage to subtract from this number, then the result will be 64 to start with, and we subtract. But we cannot, because this is bigger than this. The dividend is bigger than divisor. So what we will do, we shift it to the right to make it smaller than this. But we shift it one time. We don't want to shift it to come here. Of course, we can subtract this from 3, but we will add to the results, only we will add plus 1 to the result. And we need to keep doing this so many times, and it's not very efficient. So we need to find, sorry about that. So we need to find the biggest shift and the number that is really just smaller than this one. So we shift from left to right. So we shift again and we check, is this smaller than this one? Yes, it is smaller. And now it was shifted by 7 times. Now it will be shifted by 6 times. When we shift to right, we reduce this one by 1. So we know it's 6. And we subtract. And this is the result. And we know it's shifted 6 times. And in binary, 2 to the power 6 is 32. And we keep shifting to the right till this number is smaller than this number. And at this point, we also subtract. And we know how many times this one is shifted, and here is 0 and this is 1, so we add 32 to 1 and the result is 33. I hope it's very clear. So let's go now to the Jupyter Lab and start typing our solution. Okay, I forget about one edge cases. Actually it's one edge cases, but it's have multiple branch. The edge cases is when the input is this number. Either the divisor or dividend is this number, we cannot convert it to positive because it's not allowed. The maximum positive number is this one. So when the input is this number as a dividend or as a divisor, we will have problem. So how we solve it? First, we have, if this number is divided by -1, we will get this number as positive, and this is not acceptable, so we need to round it to this number. This is one edge case. Another edge case is this number divided by any number, or the dividend is this number, or the divisor is this number. We cannot convert it to absolute, so we have to treat it. I will not explain in detail. When I write the code, you will see the code how to treat this one. By the way, you may find many solutions that have code much simpler than my code, and if you test it in the Leetcode, it will work also. But the problem that it's not correct, because the Leetcode is only checking the output is around these 2 points, while also should check the absolute value. When we convert it to absolute, the problem is Python, it's not 32-bit signed integer, so we can convert this one we can convert it to positive without any problem, and the solution will work. We can convert this one to positive with any problem, and the solution will work. But if we try it in another environment that cannot accept this number as positive, the solution will not work. So I will pretend Python cannot accept this number as positive, and I will treat it this way, and I will write my solution in this way. So let's go to the Jupyter lab and write our solution. So first I will say, do we have edge case? I will start with false. We don't have edge case. I will find whether the solution will be positive or negative. I will say dividend, is it less than 0? So it's negative x, or divisor is less than 0. So either one of them is negative, it should be negative. If both negative is positive, both positive is positive. So we come here to edge case. If divisor equal to this number 1, oh, let me copy it from here. Wait a minute. Okay. Then we have edge case. If negative, so I will explain this. This is the divisor. So we are dividing dividend by the divisor. If the divisor is this number, so the result could be 0 or 1 or -1, because the dividend cannot be bigger than this to have like answer 2 or 3 or 4. So it's either this is equal to this, and the result could be 1 or -1. It could not be it cannot be -1, because the positive cannot be this number. Could be only the positive can be this number -1 here, 7. So it's either 0 or 1 actually. So if negative, that means this number is positive, and as absolute value it should be only less than this number, so we know the result will be 0. Cannot be any other possibility. Elif, if this number actually is negative, so it could be negative same number, the result will be 1, or negative technically bigger number, but as absolute value less than this, so the result will be 0. So dividend equal divisor, in this case we return 1, else what's left is return 0. This is for edge case solution. So now we come to another edge case solution, and which is I should put this here actually, else, yeah. If dividend equal this number in negative again, and or why I put it here, we already this is for dividend. Now the condition is for dividend, and if divisor equal minus 1, so as you see, this is another edge case. The result will be this number but positive, and we cannot have this number as positive because it's out of our range. So we retain the same number but 7 here. This is our inside the range, and we will say the edge condition is true. We have edge. I will and dividend, I will make it to this number. It's kind of the edge case here is confusing. So why I did that? Because for divisor to be this number, and later we will convert dividend and divisor to absolute value, and I convert it to absolute value, I cannot have positive number like this one. We solve the edge case for the divisor when the divisor is a problem. Now we have a dividend is a problem, and we cannot convert this to a positive number. So what I did, I removed 1 from it, from here, from 8, I converted to 7, and you see I converted to 7. This another edge case, I converted to 7, and later I will add this one and do another calculation. So now I will divide this one by the divisor, but I removed 1 from here, so at the end I will add this one to the dividend, what's left of the dividend, and to see if there's another divisor or not. Okay, so here I will convert it to absolute values. Okay, and divisor also. And I will start the result with the 0. And now we do our iteration. For I in range 30 minus 1 minus 1, if divisor shifted by I times less or equal to the dividend, okay, we say dividend minus equal divisor, which is shifted by I times, and the result plus equal 1 shifted by I times. And yeah, here we say result equal minus result if negative. If not, just result itself. Now we come to the, I removed 1 from here, remove from 1 here. Let's solve it. So if we have edge case and dividend, we will add this one, and if divisor is less or equal to the dividend, okay, we will say result equal result minus 1 if negative, else result plus 1, and we retain the results. Okay, let me take this code and go to the Leetcode and test it there. Let me see if there's any, yeah, there's error here. If divisor, where is it? If divisor, okay, here, that's a problem. So let me expect it here for I in range, yeah, for I in range, and we need to give the correct indentation here. Okay, let me test it again. It looks fine. Let me copy this code and go to the Leetcode website and test it there. Let's click submit, finger crossed, and wrong answer. There's some error here. Input -1, divisor 1, and the output is 0. I make a mistake here somewhere. Let me find it. I'll get back to you. So I find the problem. The problem here is misspelled dividend. Let's test it again. Hopefully it will work now fine. Another problem, divisor is wrong. It's not divider, it's divisor. So many spelling mistakes. And let's try again. Okay, sir, dividend, if divisor, other side dividend, okay. Divisor, dividend. Again, I think there's, let me take this. And yeah, another spelling mistake. Yeah, and yeah, 100% and 91%. It's great. Thank you very much for watching. Please leave a comment and I see you in the next video.